quiz or practice quiz number 4 here. We got a quiz, of course, quiz number 4 on Monday. It's going to look a lot like this. Not necessarily the same equation or equations that we use, not necessarily the same, A, B, but it's going to be one question, right? It's going to be one question, and it's going to be rather straightforward in terms of, identify that it's group A or group B, pick from your group of equations, group A or group B, pick the equation that fits the best, and then solve it. This one says a driver of a 1,200 kilogram car traveling at 90 kilometers per hour applies the brakes and comes to a stop over a time of 8 seconds. I'm going to actually circle this kilometers per hour to draw attention to the fact that I need to convert that. If this is just a group A problem, right, if this is just a group A problem where we use V is equal to delta D over delta T, I could actually leave it in kilometers per hour and convert this to hours. But if this is a group B problem, which I think it clearly is as we read the rest of the question, then we need to be in meters and seconds in meters per second. So I'm just circling that to remind myself that when I write down my givens, I've got to convert that to meters per second. We want to find the acceleration of the car and the driver as the car is stopping, and we want to find the displacement of the car and the driver as the car is stopping. Now, there's no reason why we have to do question A first. If this is a quiz on Monday, and you've got an A and a B like this, and you want to do B first, go ahead and do B first. I don't care. If you want to use your answer from B to help you with A, go ahead. We don't usually need to do that, right? Usually there's no reason why we can't do A first, but if something jumps out at you for B, go ahead and do B first. Doesn't make any difference. I'm going to write down my givens here. I'm not even going to write down the mass. The mass doesn't matter here, right? The mass starts mattering in the next unit when we talk about, remember we said kinematics is a study of motion without regard to what causes it? In the next unit, we study motion with regard to what causes it. In other words, we study forces, then we need masses. But we're not going to need mass through this entire unit, so I'm not even going to write that down as a given. I'm going to write down a velocity is 90 kilometers per hour. Is that VI or VF or just V? VI or VF? That's VI, the initial velocity. And how do we convert that to meters per second? You guys remember that? There's really two conversions we have to do here, right? Oh, you're taking a shortcut. And that does actually work, and that'll work every single time. But I want to make sure that everybody knows how to do the conversion, understands the conversion here before we do that, okay? So we've got 90 kilometers. That's 90,000 meters, right? 90 kilometers on the top or 90,000 meters on the top. On the bottom, we have 1 hour, but 1 hour is 3,600 seconds. So I'm going to multiply by 1,000 to get meters on the top, and then multiply by 3,600 on the bottom, which is the same as dividing by 3,600. Multiply by 1,000, divide by 3,600. That gives me, I think it's 25 meters per second. VI is 25 meters per second. I've got a time interval here of 8.00 seconds. Is there anything else that I have if I read between the lines? It's not explicitly stated, but it's kind of stated here. Yes, VF is equal to 0 meters per second. Kilometers per hour, meters per second. That's the easy conversion, right? 0 kilometers per hour, 0 meters per second. Now we want to find the acceleration and the displacement. Like I said, I don't really care which one you do first. I'm probably going to do A first just because it looks like it's easy enough to find. What equation do you want to use looking for A, given VI, given VF, given delta T? Which one is likely, Lucas, the one you're going to use? Yeah, probably. A is equal to delta V over delta T, right? But as long as, we've said this for a few days now, as long as you're choosing a group B equation, one of those 5, right, the group of 5, then it doesn't really matter which one you pick. You can't go wrong. The worst case scenario is you either solve for something else that you're not looking for, which is okay, because that just becomes another given, or you can't solve for anything at all, and then you just try a new equation. Delta V is VF minus VI. That's 0 minus 8 meters, sorry, 0, no it's not. It's 0 minus 25, isn't it? 0 minus 25 meters per second over a time interval here of 8.00 seconds. That gives me, I think, 3.125. Negative 3.125, is that right? Which technically we should round that to how many digits? We got 3 digits. Negative 3.13 meters per second squared. Does anybody know why I wrote down the unrounded number there? That's a 3.125. I got to round that to 3 digits, right? If I look up here, this is 4, although this doesn't matter because I didn't use it. This is 3 digits. This is 3 digits. I round my final answer to 3 digits. But why did I bother writing down the 4-digit answer, the 3.125? Why didn't I just save the bother and write down 3.13 right off the top? Yes. In case I know there's a B. I know there's a question B. And I don't know for sure that I'm going to use the answer from A in B, but if I do, I want the unrounded number in question B. That make sense? If I use this acceleration, I don't want to use 3.13, I want to use 3.125, or actually negative 3.125. Always use the unrounded number. All right, that's question A. Now question B, you can go back to the original givens, but you can also use 3.125 if you want to solve for the displacement. What do you want to do here? Anybody? No, you can't go wrong, right? Number 4, d is equal to VIT plus 1F, sorry, d is equal to VI plus VF over 2 times T. How many people did that? That's probably what I would have done as well, just because that takes us back to our original data. It doesn't depend upon not making a mistake in question A. VI is 25, VF is 0, and delta T is 8 seconds. What's that going to be? 200, 100, I think? Anybody do it differently? Equation 2, d is equal to VIT plus 1/2 ET squared. I was expecting that actually from somebody or more. So d is equal to VIT plus 1/2 AT squared. VI was 25, T was 8. The acceleration was negative 3.125, and the time was 8.0 seconds. That's 200, and I think this one ends up being minus 100. Colton, you got the right answer there? 100 meters? Go figure, right? If this is a test, and you have until 10 o'clock to write the test, and it's like 9:40, and you're done the test, like, go back and try something like this, right? Go back and try a different way. If you got it like this, and then you go and do it like this, and you get the same answer, like it almost has to be, right? Like you're not going to get the same answer doing it 2 different ways, especially when one of the ways depends upon an answer from question A. That makes sense? Like you're almost assured of having the right answer if that's the case. Now, having said that, I don't want you to do it 2 different ways as you're writing the test. Like don't spend a half an hour on a question doing it 2 or 3 different ways, checking your answer until you're done the test, right? You might run out of time and have 3 questions at the end of the test that you didn't finish if you do that. It's more important to finish the test and then go back and check it if you need to. Okay? Good.